Hello guys, welcome to my YouTube channel. Have you ever thought of using Microsoft Word to type your mathematical assignment and document? Do you ever wish to learn how to use Microsoft Word to type mathematics? In today's video, I'll introduce you to the basics of using Microsoft Word to type all your mathematical document and assignment. So in today's video, I made this purposely for this video. We are going to learn how to use Microsoft Word to type fractions, equations, both linear and quadratic, trigonometric expressions, binomial expressions, general formulas, matrices. So before that, if you are new to this channel, please do me a favor by liking this video and subscribe. This encourages me to do more videos like this, which will make you more enlightened and knowledgeable. The first thing I'm going to do is that I'm going to open a new page, a blank page, so that we learn this over the view to landscape. So you click on layout, you navigate to orientation, you change it from portrait to landscape. So I would like to divide my workspace into two parts. So I'll go to columns and make it 2. So it means I can write at this side freely and write at this side freely. Now, before we start, I'll take you through a brief introductory aspect of today's lesson. In order to type mathematics in Microsoft Word, you go to Insert. Now, at your extreme right hand side, there are two menus up here. You have equations and you have symbols. This is what we use to type all our mathematical formulas and equations. So I will click on equations. Now I will take you through this briefly. Now this first thing here is the fraction. If you want to type fractions, this is where you navigate to fractions. So this is how it looks like. The next is script, which means that any variable which has an exponent or it has a value as a subscript or superscript. So if you have a subscript value, a superscript value, then you need to introduce the script icon. Now we have the radical. We have the radical. Now this radical is the square root sign, whether it's a cube root, whether it's a square root, any root sign can be located in the radical. The next menu is the integral sign. Now this is the normal integral sign. If you have limits, integral with limits, then you use this one. You can scroll down to see any form of integral sign that you want. Now this is the summation or the large operation or the large operator. So you have summation, which is the normal summation, and summation with limits in that sequence. Now this is product and co-product. So if you need anything of this nature, you move to large operator. This is the union and intersection. You have this sign too, that's other large operators, which can be found in large operators. That's the summation sign. When you navigate to this side, you will get the summation sign here. The next is the bracket. Now this bracket is very important in a mathematical arena. We use bracket to signify a lot. So this bracket sign, you have various types of bracket sign here. So this is it. Anything that needs to be in a bracket, you come to the bracket sign of the menu. The next is the function. This is where we can find our trigonometric functions. We have sine, we have cos, we have tan. If they are in inverse form, we have the inverse function, sine inverse, cos inverse, tan inverse, and a whole lot. Hyperbolic functions, these are the hyperbolic functions, and we have the inverse hyperbolic functions, common functions. These are the common ones we know. Sine theta cos 2x, tan theta is equal to sine theta over cos theta. The next menu is the Ascent. Now, if you want to put an Ascent on a variable, this is where you come. This is where you're going to find that. So let's say if you want to write x bar, which means that the mean of x. So this expression is the bar. So you click on it and you input the x inside the box which has been provided. Don't worry, we are going to go through that. But before that, I just want to take you through this introductory part. So if you have any variable that you want to introduce an Ascent on, then you navigate to Ascent. So we navigate to limit and log. You have logarithm with empty boxes. So now with this, when you have a logarithm function like log base 2, 5, so you can use this expression to type that. So this is a logarithm with no base. Usually we assume logarithm with no base to have a base of 10. We have lim, we have the limit, you have minimum. If you want to express a minimum in an expression, a maximum, lim, you can find them at limit and log. The next menu is the operations. If you want to use operations in your expression, show direction, any operation sign, you locate operators in the mathematical formulas up here. The next is matrix. So this is your 1 by 2 matrix, this is your 2 by 1 matrix, this is also your 1 by 3, this is your 3 by 1, 2 by 2 in that sequence, this is your 3 by 3 matrix, and this is your dots. So if you are setting a matrix where you want to introduce dots and write a note using matrices, you can use them. You can use these dots to indicate that you have identity matrices, you have matrices with brackets, and so on and so forth. The next is to look at these symbols. We've looked at the equations. Now let's come down here and look at the symbols. These are the basic mathematical symbols, that the basis that we know. Addition, equal to, greater than, less than, approaches, and so on and so forth. The next is the Greek letters. The Greek letters, we have alpha, we have beta, we have gamma, we have delta, we have lambda, and so on and so forth. So all these are the Greek letters in lowercase, and these are in upper cases. So if you want the Greek letters in lowercase, you use these ones, and in uppercase, you locate them here. They are all under the symbols. So you use this side to change them. Now, if you want a letter-like symbol, this is how they look like. So letter-like symbols, you come here, and any symbol that you need for your expression, you can find it here. The operators, binomial operators. So we have the common binary operators. The common binary operators, addition, division, star, greater than, less than, union, intersection. We have common relational operators. We have the basic n-array operators, advanced binary operators. So these are the advanced. So when you are setting a binomial expression and you need summation, star, summation, addition, you can find them here. And we have the advanced operational operators. They can be found at the operators. So if you need any operator, you navigate to operators and you find the sign and symbol over there. The next is the arrows. These arrows can be used to show direction, to show whether a variable approaches or another expression approaches another. You can find this arrow also in the symbol arena. We have negated relations. So any positive relation has its negated relation. So equal to, not equal to, greater than, not greater than, less than, not greater than, union, not a union. And you can find all at the negated relation. You have your scripts. So these are the scripts. You have the fractures, you have the double stack, and these are they. If you want to use the double stack in your write-up, you locate them at symbols. The last is the geometry. So these are the geometry signs. If you are typing mathematics and you want to indicate therefore, you don't write English therefore, you just use this geometry sign. If you want to type because, you don't type the full word because, you use this sign to indicate because. So you find them at the geometry side of the symbol. So quickly, let's dive into today's work. I'll minimize this so that I see what we are going to type. So the first is our fraction. So the first fraction is 25 whole number 1 over 2 plus 15 whole number 3 over 2 minus 10 whole number 1 on 2. So they are fractions. So let me indicate fractions. So now if you want to type your fractions, the first thing is that you click on insert, go to symbols, click on the equation sign. I want to align to the left. So let me number it. So go to insert, symbols, equations. Now, the first is 25 whole number 1 on 2. So I'll first type the 25. I need a fraction, so I'll click on this fraction and click on this tag fraction. So this is how it's going to appear. You make sure where you are about writing in has a shaded region. That will indicate that that portion is where you are going to write in. It is very important to note that. So 1 on 2. So you move your arrow to the other side, plus the next is 15 whole number 3 on 2. So 3 on 2 minus 10 whole number, the next fraction is 1 on 2. Very beautiful as that. So that is our first expression, our first fraction. The next one is 75 bracket open 2 on 3 minus 1 on 5 minus 2 on 5. So this first we type our 75, sorry. You click on insert equations. Now this is a bracket, we have a bracket which contains fractions. We have a bracket which contains fractions. So we click on brackets and take this bracket. Within the bracket, so you change the direction or the position of the arrow into the bracket, and we have our fractions in. So you have your fractions in like this. So 2 on 3 minus, you have your fraction 1 on 5 minus the last 2 on 5. That is it. The third fraction, so now we've seen how if you have a bracket which contains fraction, you indicate it in your Microsoft Word. Now the third expression is another fraction which contains brackets and a lot of fractions. It is very simple to type an expression like that. So you go to insert your equation, so click on your equation, you move to your fractions. So this whole expression is the numerator and this is the denominator. So it's still on a fraction, even though this contains a lot of fractions, it's a fraction on another fraction. So on the numerator, we need a bracket. So you introduce your bracket. Within the bracket, we have another fraction. So you locate fraction. At the numerator in the bracket, we have a list of fractions at the top. So you locate the fraction also. So we have 1 on 3 minus 1 minus, we have 2 whole number, 1 on 5, 2 whole number, another fraction, 1 on 5. Now we come to the denominator of the numerator. You have a fraction 1 on 5 plus another fraction 3 on 4 sorry, the negative sign, another fraction 1 on 2, 1 on 2. So we are done with the numerator. We come to the denominator, that's 30 whole number 2 on 5, 2 on 5. So we've been able to type that. I believe we are all learning something. So I can choose to increase the size so that we can see it very well. Okay, so you can pause this video and type as many fractions as you can to make yourself more abreast. The next is our equations. Both linear and quadratic. So the first, we have a linear, that's a linear equation because the variables has no exponent more than one. So the first, so you have y equal 25 plus, so you have a fraction, that's 2 on 5 x. That's simple. The first is very simple. The second contains a superscript. So you navigate to insert symbols and equations. You click on that. So that's Q, that's a capital Q equal. Now you have x cubed. So it has a superscript. So we are not going to use a fraction here now. We're going to navigate to script. Now this script, we are not going to pick this or that. We will pick the first one because we have a superscript of 3. So you click on that. The superscript is 3. The variable is x plus. The next also has a superscript of 2 and 4x. So 4x minus, we have a fraction 2 on 7 x plus 10. Very simple as that. Please, if you are new to the channel, don't forget to like and subscribe. Now the third expression has a subscript and a superscript and a fraction. It has a subscript, superscript, and a fraction. Also contains a bracket. You get it? So you still navigate to insert symbols, equations. Now we'll go to script. We need a subscript and a superscript. So we click on that. Our superscript is alpha. So you go to symbols, go to alpha is a Greek letter. So that's, you go to Greek letters and you navigate alpha. The variable is u and the superscript is 1. So we are done with the first one. Equal to, now it is equal to a certain fraction. So you take your fraction. On the numerator, we have 4x exponent alpha. So we'll still need a superscript. So 4x, so that's a bigger x, exponent alpha, so that's alpha, y, so y also has a script a superscript. So that's alpha minus 1 minus 1 as its superscript, and the value itself is y. So we come to the denominator. Now the denominator also contains a fraction, contains a bracket with an exponent of -1. So what you do is that you click on your script and with the part that contains x exponent alpha, you introduce your brackets over there. So we have our bracket here. And within the bracket also has another exponent. I hope we are seeing that. So you take your time, go through this video over and over and get yourself abreast with how you arrange the alphabet in. So our x exponent, you have alpha, and the whole expression has an exponent of -1. So you are done. So you've duplicated that beautifully. The fourth equation is our integral of df over dy. If you integrate df over dy, you get a function of y and t. So quickly, how do we input this expression? So you go to equations, okay, so equations. Now we want our integral sign, integral with no limit, the normal integral sign. So you introduce your integral sign, and where do you find df over dy? So you can just introduce your fraction, and on top df in lower script, df on dy. That's is equal to integral of, we need a bracket also here. So you introduce your bracket. Within the bracket, you have y exponent 2. So you need a script. So y exponent 2 minus another script t exponent 2. T exponent 2 all times dy. So that is that. You've beautifully duplicated that. The feed equation is a logarithm. So it goes limit and log. This is log of base 2 25 or log 25 base 2. So 25 and has a base of 2 plus you have log base 2 15 minus log base 2. Now this, we have an exponent, we have a bracket. So the first is you take your script and you introduce your brackets as well. It's because we've partitioned, because we divided the workspace into two. Okay. So you have lambda minus 10 exponent 2. So where do you locate your lambda? Lambda is a Greek letter, so that is lambda minus 10 exponent 2, which is equal to 0, which is equal to 0. So that is that. Okay. So we've been able to write fractions, equations. Our next thing is to look at the trigonometric. We're going to look at the trigonometric expressions. Let me increase. Okay. So that's beautifully displaying. So you have trigonometric expressions. You have sine 90 cos 45, tan inverse of theta, tan theta equals sine theta over cos theta. With that, I wouldn't type that because I went that through with you. So this is where you can locate that. So this is sine, this is cost. So you can locate them at functions. So cost any number, cost tan any number, you can locate them here. Tan inverse of any number can also be located here. Hyperbolic function of any number. So all you need to do is you click on it and you input the value there. So I would like us to move to the other side. So this is the binomial expressions. So let's input that binomial expression and move on. So on the other side of our page, as we divided it to 2, is our binomial expression. It's just one, so I'll just leave it as an expression. So what do I do to get this table? So I'm going to draw the table. So very sizable. Yes. So after drawing, I'm going to split. So I want a 4 by 4, 4 rows, 4 columns. So 4, 4. Yes. So now I can introduce my operations sign as a star or a plus. So you go to insert, equations. Now at your symbols, you change to operations, that's operators, and I'll move down to the basic NARC operators. So you can see that I have my operation star here and the operation plus sign here. So I'll click on the star. So the rest is just left to key in the normal values. So that is how it is done. So the first is you draw your table. Now if it is a 4 by 4 matrix, a 4 by 4 table that you want, that's 4 rows, 4 columns, that is done. A 3 by 4, any proportion that you want, you key in the split section and you split the table into the proportion that you want. Quickly, let's type this general formulas. So the first formula that we are seeing is the estimated beta naught formula. It is used in econometrics. So if you estimate, that's in a regression model, a linear regression model. So beta is beta hat. So it is a Greek letter. So, and as we can see, it has an accent on it. So quickly, before we type in that, let's look for the hat. That is the hat sign. That is the hat sign. And also, it has, let's do it right. It has a superscript. It has a subscript. Sorry. So script, we have a subscript of 0, and the value itself has an accent hat on it. So that's beta, that's beta hat. So that's what we've typed neatly. So when it has, when your expression have what's the name, a superscript or a subscript before an accent, make sure you do that before bringing the accent, else the accent will spread out on the superscript or subscript. We have y hat, y bar, that's the mean of y. So we go to the accent, locate the bar, that is the bar. You key in y there, your addition sign, that's beta hat 1. Beta hat 1. We have a subscript of 1, and the beta has an accent of hat, that's estimated beta hat. So that is that. And you have x bar. You have x bar. That means x has an accent. So beautifully, we have duplicated that. We have duplicated that. Sorry. Let's do this again. One. This one has an accent. Beta hat 1. That's beta. So that's estimated beta hat 1. Now x bar x. That's beautiful. So it approaches or is the same as what the arrow is showing. So I showed you how you get your arrow. You go to arrows and you have the one which points out this way. Now we have a fraction and some summations on top. This value, this expression that we are seeing is the same as what I'm about keying in again. So we need the summation sign. So summation y minus it has a superscript, a subscript, that's 1 and an accent of hat, and the value within is a Greek letter, that's beta. We have summation again, summation x all on n. So we've been able to type that neatly. So the next one is our R value. So R equal, you need your fraction. On top of the fraction, we have summation. The first has a bracket. We have x minus x bar. So x bar has an accent. So x, we need another bracket also. Y minus y bar. So y bar also has an accent, so you need to introduce that. Now at the denominator, we have some expressions. You have square root of a lot of elements within. It is nothing strange. You go to the radical, you pick the first one because it's a normal square root. Now the whole bracket, the whole square root has a bracket within a bracket. So first we introduce this bracket. Now x minus x bar has an exponent of 2. So we introduce that. You need to make sure that your shaded portion is within the box, else you write a different expression. So now within this we have another bracket, which is this. So we can type our x minus x bar. X bar has an ascent, so x bar all exponent 2. So we are done with the first one. Very simple. So the second one is the bigger bracket, and within that we have a superscript which has a bracket of y minus y bar. So y minus, we have an ascent, y bar all exponent 2. So we've been able to write our R, that's our coefficient of determination. So we label that. Our third is our variance of beta hat. Our variance of beta hat. So quickly, insect. So variance of beta hat. So within is our ascent. So with this, the more you do it, the more you become abreast and more smart and faster. So you keep doing it over and over and you become more experienced. So we need this operation sign, that's var of beta is equal to s prime s inverse times lambda, s prime s inverse times sigma squared. Yes, and we have our sigma here. We have our sigma. So squared sigma is a Greek lowercase. So yes, we have our sigma squared. Now the bracket has an exponent of -1. That's the inverse. So we introduce our bracket also. So x prime, you can type the prime on your keyboard. Mine is shift plus the less than symbol. Sorry, let me type the value first. X so x prime x. So that is that. So with the prime, you can locate it on your keyboard. So you find the kind of keyboard you're using and you do that. The last is our metrics. The last is our metrics. So let's move to another page and do our metrics on that page. So metrics. So as we saw in our previous overview, so that metrics we can have a 1 by 1, a 1 by 2, a 2 by 1, a 1 by 3, a 3 by 1 in that sequence. So these are 3 by 1 metrics. These are 3 by 1. So let's pick this and indicate our metrics in that. So let's delete. Yes. So you have 4, 5, and 6. That's your 3 by 1 matrix. So with the matrix, it's very simple to key. All you need to know is where to locate it. So let's type our 3 by 3 matrix. So this is a 3 by 1 matrix. So the next one is a 3 by 3 matrix, which means the matrix has 3 rows, 3 columns. So you go to insert, equations, your matrix. Now you can quickly get a set of matrices in parentheses already, but we want a 3 by 3 matrix. So quickly we pick this bracket, and within that we introduce our 3 by 3 matrix. So this side has 0, 6, 4, 6, 2, -3, 4, -3, and 5. So that is that. We've been able to key in our 3 by 3 matrix. So basically we've been able to key in all our practical work. We've been able to key in all this. This is just the basis. This is just the basis. I believe you've been able to learn something new and it has impacted your knowledge base. Please, if you find this video interesting, motivate me by liking it and subscribing.